Hi, welcome back to my channel, and this time we'll be continuing what we have not finished the last time about lines. So the last part of the video was we are going to evaluate parallel and perpendicular lines with this 3x plus 2y minus 5 equals 0. So before we start, we're going to evaluate first, or we are going to know first what are those parallel and perpendicular lines. So as we can see back in our elementary days, we have a basic geometry. These lines that never intersect with each other, and at a certain point in here and a certain point in here, the distance from this point and this point is the same as when we pick another distances here. So technically, there's no way possible that these two lines can intersect, even if we extend these to infinity. Now, when we say intersecting lines, so any line that looks like this, if we extend that, there's a certain point at which these two lines intersect with each other. So that's intersecting line. Now, one special example of intersecting line is perpendicular line. So these lines intersect at a common point, forming a right angle. So technically, these two lines will form 90 degrees. So that those two lines are called perpendicular with each other, or perpendicular lines. That's it. Okay, now we are going to discuss a formal mathematical definition of those lines with respect to their corresponding slopes. So let's consider this definition. Given M sub L1 and M sub L2 be slopes of lines L1 and L2 respectively, we say that L1 is parallel to L2 if M of L1 is equal to M of L2. And L1 is perpendicular to L2 if M of L1 is equal to the negative of 1 over M of L2. That's it. Now, what does it mean? So technically, if you have to get the slope, let's say for example, you're given two equations of two lines. So you are going to solve individually the slope of each line, and if you found out that those two slopes are equal, then those two lines are parallel. Otherwise, it's not otherwise. It's actually if you get one is, let's say, get 5, the other one is negative 1, 5, then these two lines are perpendicular. That's it. So how do we picture this out? If you are given a graph of a line here, so this is L1, another graph here, L2. So if they are parallel, technically they are the same, because even if you compute here the rise over run, they're actually equal. Now, when you say there's another line here, let's say L3, and this forms the right angle here, let's say with respect to L1, then technically if you get, let's say for example, if you get 5 here as the slope, so technically this is negative 1 over 5. Basically because it goes to the opposite direction, and it's actually the reciprocal of the slope of the first line. That's it. Okay, so we'll be considering an example here. We'll use the equation we've presented on the last part of the previous video, the 3x plus 2y minus 5 equals 0. This time, find equations of the lines parallel and perpendicular to the line 3x plus 2y minus 5 is equals 0 and pass through 0, 3. So both the parallel and the perpendicular line pass through 0, 3. So basically, if we're going to graph on this, let's say here. So how do we graph the equation of the line again? Let's get the intercept. So if y is 0, x is 5 over 3. So somewhere here. 5 over 3 is actually 1 and 2/3. So somewhere here. If x is 0, y is 5 over 2 or 2 and 1. That's 2 and 1/2. So 1, 2, somewhere here. So this is our line. Now, we have to find a line parallel and perpendicular to this, which passes through 0, 3. So our 0, 3 is somewhere here. So basically, our parallel could be like this. So something that is parallel to here. Or our perpendicular can be like that. That forms 90 degrees with respect to this line. Okay? Now, let's solve first the parallel line. So in order for us to do that, we'll have to get the slope of this first. So solving for the slope, you'll get 3x plus 2y minus 5 equals 0 implies 2y equals negative 3x plus 5. So divide both sides by 2, you get y equals negative 3 over 2 x plus 5 over 2. So this is only the important thing here. So this is the slope of this line. And since we have to get the parallel of this line, so this is actually the same slope. So solving for the parallel line, so this is parallel line. So that's y equals mx plus b. So your m is the same, negative 3 over 2x. Our b, this is already a y-intercept point because x is 0, so plus 3, and that's it. So therefore, your equation of the line is y equals negative 3 over 2x plus 3. So that's the equation of the line. So how do we plot that? When x is 0, y is 3 here. When y is 0, so x becomes 3x over 2 equals 3, so x equals 2. Because if you divide both sides by 3 over 2, that's 2. Yeah, you get it 2. So therefore, this is where the line passes through. So this is now the graph of the line parallel to the equation. That's it. Now, if we have to solve for the perpendicular line, so the slope becomes the negative reciprocal. So get the reciprocal of this, you get 2/3. So this is negative, so negative with negative becomes positive. So therefore, solving for perpendicular lines, y equals 2/3 x plus 3. That's it. So this is now the equation of the line perpendicular to this equation. So if you have any question, you can comment down there. By the way, I just presented this result in a slope-intercept standard form. So this is actually a general form of the equation of the line. But whichever would you like to present your equation, that's still the same. That's still correct. Okay, so we'll consider another example here of find an equation of the line A passing through the center of the circle x squared plus y squared minus 6x minus 4y minus 3 equals 0, and parallel to 5x minus 2y minus 9 equals 0. Okay, moreover, find the equation of the line perpendicular to line A and passes through to 3. So there are two things that we have to solve here. First is we have to get the equation of the line A, which is parallel to this equation and passing through the center. Now, second is, once we get the equation of the line A, we need to solve for an equation that is perpendicular to line A and passes through this point. Okay? So first is we have to get what's the center of here, because the line A passes through the center of the circle. So we will recall again on how to get the center of the circle. So we have to rewrite this equation in a standard form of the equation of a circle. So x squared minus 6x plus y squared minus 4y equals 3. So we have to convert, we have to group x, those with a variable x, and we need to convert them to become a perfect square. So note that the middle term here is negative 6x. So half of negative 6 is 3. Therefore, if you get the square of 3, you get 9. So therefore, you can add here as 9 plus 9 here. So this center for what with respect to y is negative 4. So half of negative 4 is negative 2. You square negative 2, you get 4. So that means you add 4. So that's here. So this is now a perfect square. That's x minus 3 squared plus, this is actually y minus 2 squared. And this is equal to, we don't care about that anymore. We only have to get the center. So the center here now is 3, 2. So this is where the point, this is where now the point at which line A passes through. So we'll have to get the equation of this, the slope of this. So we can erase this here now. If we rewrite this becomes 2y equals 5x minus 9. So this becomes y equals 5 over 2x minus 9 over 2. So your slope is 5 over 2, which is, this is also the slope of line A. So this is now the point. So solving for the slope, solving for the y-intercept first. So y equals mx plus b. This becomes b equals y minus mx. So what's your y here? This is 2 minus the slope, which is 5 over 2 times 3. So you'll get 2 minus 15 over 2. So this is 2. 4 minus 15. So that's negative 11 over 2. So therefore, the equation of the line A is y equals 5 over 2x. Our y-intercept is negative 11 over 2. That's it. Now, how do we get the equation of the line perpendicular to line A? This is already the line A. So so we'll have to take the slope of the perpendicular line to this. So the slope here, it becomes negative 2 over 5. So solving for the line perpendicular to that, we'll have to solve. Okay, so y equals mx plus b. So your b equals y minus mx. So your y here is 3 minus negative 2 over 5 times your x is 2. So you'll get 3 minus plus rather, this becomes 4. So this is 5 15 plus 4, so you'll get 19 over 5. So this is now your y-intercept. Therefore, your equation of the line perpendicular to line A passes through this is y equals negative 2 over 5x plus 19 over 5. That's it. So if you have a question, you can comment down there. Okay, so let's consider another example here. Find an equation of the line passing through the point of intersections of lines 3x plus 2y minus 13 equals 0 and 2x minus y minus 4 equals 0 and parallel to the line that is perpendicular to 3x minus 4 minus 5 equals 0. So how do we interpret on this? We have to find an equation of a line, and this line passes through the intersections of the intersection point of this point. Now, this line is actually parallel to another line, and this line that is parallel to this is actually perpendicular to this line. Okay? Now, before we have to solve on that, we'll have to remember first, or we have to consider the axiom first, at which if two lines intersect with each other, such point of intersection is actually unique. So what do I mean with that? When we say unique, let's say for example, two lines intersect with this. So this is now the point of intersection. There's no way we can find another point at which these two lines can intersect aside from this. Okay? So which means if we are able to get the intersection point of these lines, that's only one. That's unique. Okay? Now, how do we get the intersection point? Simply, we have to solve the value of x and the value of y in these two equations. Now, 3x plus 2y minus 13 equals 0, and you have 2x minus y minus 4 equals 0. So we can solve this using elimination method. I can multiply this equation here by 2 on both sides. So I shall get 4x minus 2y minus 8 equals 0. So I can erase this one, I can remove this, and so this is negative 2y plus 2y, so this becomes cancelled. So I have 7x when I add this, and I get 21 equals 0. Solving for x, you'll have 3. Okay? Now, how to solve for y? So we can use substitution method using in this equation. So this becomes y equals 2x minus 4. So you'll have 2 times 3 minus 4, so you'll get 2. Therefore, the point of intersection is 3, 2. Okay? Now, second is we have to get first a line, this line, that is perpendicular to this equation. So you will have to solve for the slope of this. So 3x minus 4y minus 5 equals 0. So you'll have 4y equals 3x minus 5. Or simply you get y equals 3 over 4x minus 5 over 4. So therefore this is now the slope of this line. Now taking the slope of the perpendicular of this line, you'll get the slope as negative 4 over 3. So this is now the slope of this line, which is parallel to this line that we're looking for. So this is now the slope that we're going to use. Now, solving first, because the line here passes through this point, so we'll have to solve first the y-intercept. So solving for y-intercept again, b equals y minus mx. Okay, so our y here is 2. Our m is negative 4 over 3. And our x is 3. So, you'll get 2 plus 4, so you'll have 6. So our y-intercept is 6. So solving for the equation now, so our slope is negative 4 over 3 x plus 6. So this is now the equation of the line that we're looking for. Okay? So if you have question, you can comment down there. Okay, so let's consider another example up here. The latus rectum of the parabola 3x squared minus 12y minus 24 is 0 is a line segment part of the line A. Okay? And find an equation of the line parallel to line A and passes through the point at the y-axis 4 units away from the origin. So basically, there are 2 answers for this. Why? I'll show you how. Observe that this is the equation of the parabola. So if I'm going to plot on that, it looks like this because it opens up, so it looks like that. Okay? Now, somewhere here is the latus rectum. So this is now the latus rectum, so which means if we extend on that, that's already the equation of the line A. Now we're going to find a line parallel to line A, so it looks like that as well. Okay, at which the origin, at which the lines parallel to this could be somewhere here or can be somewhere there. And it's 4 units away from the origin. So 4 units away from the origin is actually the point 0,4 and the point 0, negative 4. So therefore, a line that passes through 0, negative 4 and 0,4 are actually the 2 lines we're looking for. So therefore, there are 2 answers for that. Now, I'm not going to solve on this one. I want you to solve on that, and you can comment down there about your answers for this problem. This is actually the simplest, the easiest questions I have presented in this video. So, if you have questions regarding how to solve this one, you can comment down there, or you can message me if you know me on Facebook or Instagram. And for those who find this problem very easy, you can comment your answers down there. Anyway, we're looking for the equation of the line, so you can just type. You don't need to LaTeX that one. So, yes. And for those who haven't subscribed yet, subscribe now because I have a lot of videos and exercises regarding on analytic geometry and some other fields in mathematics. Okay, so that's all for now. Thank you so much for watching, and thank you to all my friends who have subscribed on my channel. And for those who haven't subscribed yet, again, please subscribe now on the subscribe button below. It's color red. Click that one until it turns gray. And you will be updated with a lot of videos about mathematics. So down from high schools to senior high school to college, or anything that I can be able to explain it to you very well. And thank you so much, and see you next time.